After completing this chapter, you will know how an ECDIS is used to assist passage making and voyage data recording. When the vessel is ready to sail and the planned route is loaded, validated and safety checked, it is then in monitor mode. At this stage, it is essential to set a level of detail on the ECDIS that enables safe and easy monitoring. If a high level of detail is left on screen from passage planning, it will result in an over-cluttered display, making it difficult to see what is necessary. The illustration shows an active route to the west from Newtown to Southern Island, with a contingency route to the east, showing in orange, not monitored but planned in case there are strong westerly winds at sailing time. Both routes are visible, but the active route for monitoring shows as a dashed red line. The appraisal process should not stop once the route is in monitor mode, but it should be ongoing throughout the whole voyage, looking for new dangers as conditions change or new information is delivered to the vessel. Examples could be encountering a large swell or a tide height lower than predicted, causing a change to the safety depth and contour settings. With an active route voyage, recording will start and continue for the whole voyage or until stopped. This is called automatic voyage recording. Recordings can be played back at a later stage or exported on inserted media. When a recording is playing, the ECDIS monitoring stops in real time. It is required that ECDIS records the following information at 1-minute intervals for the previous 12 hours. Date and time. Position. Heading and speed. ENC source. Chart edition. Chart cell. And chart update history. Over the whole voyage, ECDIS has to be able to record the entire voyage track, and time marks at least every 4 hours. It should not be possible to change any voyage recorded information. Some ECDIS devices also have a logbook facility that will record notes similar to those entered into the bridge notebook. These records can also be viewed, as they are saved on the ECDIS computer. The vessel's predictive vector is a very useful tool and is set for a number of minutes. The length displayed is then a function of the vessel's speed. The illustration shows a ground track vector almost touching the safety depth contour. The vessel has the vector time to take action to avoid crossing the contour. We also see a conical-shaped look-ahead sector set up as a guard zone with similar function to the vector, but over a larger area. Both will cause an alert if they sense danger. Getting the right length of vector is important to safeguard against grounding. Too short a vector gives insufficient time to take action. Too long a vector can cause continuous alerts in areas close to navigational hazards. The illustration shows the vector is too long for this leg of the route in a pilotage area and sets off an unnecessary alarm. Maintaining the safety of the vessel is all about knowing where it is now, but also being aware of where it will be in the future. In open water, this would be the next few hours, but in areas close to danger, it is the next few minutes. The predictive vector helps develop situation awareness. Some ECDIS allow a geographic footprint to be set using distance measure rather than time, giving all-around protection to the vessel. There is then an automatic check using the largest scale chart of all objects in the SENC, whether displayed or not. Certain dangerous objects cause an alarm, but other objects will cause a warning or caution. In monitor mode, there is a window that can be displayed showing lots of information concerning the route, as illustrated in the text and shown on the window. Common alarms from the monitor page are shown in the text. The exact abbreviation for the alarm differs from manufacturer to manufacturer. Some, like the last one illustrated, can be very explicit. On a passage, the navigation system drives the vessel symbol across the chart, leaving a track line. There can be cross-checks between primary and secondary navigation sensors, with warnings if a large discrepancy occurs. However, it is recommended that the vessel's position should be checked by other means to ensure the ECDIS is displaying the correct position. Click on the button for more positioning information. A sound principle of navigation is to have some redundancy in the position fixing method. ECDIS, fed with Navstar GPS signals, only has no navigation system redundancy, as it is using only one system, even though there could be two independent receivers. The illustration shows a variety of positions that can be entered by the operator as a check on the GPS. These manually entered positions are also recorded. An ECDIS in track control mode sends the active route to the autopilot that then steers the vessel along it. This sounds an alarm as wheel-over positions are approached that the watch-keeping officer needs to accept to allow the autopilot to steer the vessel onto the next leg. There has to be compatibility between the autopilot settings and the route settings for track control to be effective. With very small safety margins in pilotage waters, it is recommended not to use track control until the bridge team are fully aware of its capabilities, including any limitations. Click on the button to see a very misleading feature of track control. Notes can be added to the ECDIS as an aid to memory or record of events. These are called mariner's notes or events, and they can be saved as records for future use. A connected radar or RPAR signal can be overlaid on the chart screen showing a green color. Any radar targets are seen, but when the radar return of buoys and land aligns with the charted objects as illustrated, it is a good indication that the navigation signal is accurate and a useful check to assist monitoring. The illustration shows that the operator has selected acquired RPAR targets to be displayed. They show with a green circular symbol and attached vector if the target is moving. AIS targets show on the ECDIS as a blue or green triangle when sleeping, but with attached vector when active. If dangerous to the vessel, the color changes to red and an alert sounds. It is noticed that the Matilda has AIS and radar return coinciding with each other. This does not always happen, because one position is from the vessel's radar, the other from the target's GPS receiver. ECDIS has a function called fusion that allows the operator to merge either radar to AIS or AIS to radar if there is separation. CPA and TCPA limits can be set on the ECDIS that alert the operator if a target is to be dangerously close. Some ECDIS show the past track of targets that adds to the operator's awareness of collision risk. It is tempting to use the ECDIS to try and predict the future track of a dangerous target and then take avoiding action that may not comply with the international regulations for preventing collisions at sea. ECDIS can be used to develop situation awareness, but maneuver decisions should still be based on the collision regulations. There are some ECDIS manufacturers that supply a collision avoidance tool that interprets the situation and offers advice based on the colregs. There are specialized uses for ECDIS as listed in the text. The illustration shows a very large-scale chart with the vessel close to the berth. The operator has selected bow and stern distances to be monitored that give a continuous measure of the berth proximity. The predictive vector is straight, but can be curved if the vessel is rotating with head or sternway. Overlaid AIS signals give pilots particularly useful safety information on the position of a tug connected to a large ship with poor bridge visibility. ECDIS is part of e-navigation that generally describes the move towards having more electronic systems afloat and ashore involved in the navigational control of vessels. Unfortunately, navigation systems and ENCs are still being developed worldwide, and until e-navigation is fully established, mariners need to show great caution using electronic systems. ECDIS is a very useful tool to develop situation awareness in the bridge team, but if not correctly set, it can also be very misleading. Remember that it is a very powerful aid to navigation, but only as good as the information it gets and how it is set up. The topics in this chapter are summarized in the text. Make sure you understand them all